trigonometric functions of sum and difference of angles. In trigonometry, we have seen what is sine x and what is sine y, right? Because if I ask you what is sine 30, it is 1 by 2. And if I ask sine 45, it is 1 by root 2. But what if I ask you what is the value of sine 75 degree? Sine 75 degree is what not we have learned till now, right? But we can write 75 is in which form? 30 plus 45. So now I have 75 which is written in the form of two known angles which is 30 and 45. But still I don't know what is the exact value of what is the sine 30 plus 45, or in general if I say what is sine x plus y, what is sine x plus y? Or what if I am writing it as sine 90 minus 15, or if I write it as 120 minus 45. So these cases where if I write in this form, I don't know the exact value, or how I don't know have the formula to find out the angle value of sine 75 or cos 74 or anything. So in these cases, the formulas for sum and difference helps us to do them. And what are these formulas? See how we got the formula for cos x plus y. So that is the first thing that we have to learn here, how we got the formula for cos x plus y, or what is the formula for that. So here I'm drawing a circle over here, a unit circle. So remember, this is a unit circle that I've drawn here. So unit circle means what? Its radius will be equal to 1. So the radius will be equal to 1. So this coordinate here will be 1, 0, right? Yes, it will be definitely 1, 0. Now I am taking another 3 points on the circumference of the circle, one over here and naming it as P1, another one in the third quadrant, that is P2, and same again in the third quadrant P3. I'm just joining these lines. So I'll be getting this one. So I have 3 points now on the circumference of the circle. And this P1, the point P1 is at an angle x. So this is at an angle x. And this angle over here, I can write it as y. And this angle over here, I'm writing it as minus y. So these are the three angles that is formed here. One is x, the other one is y, which is between P1 and P2. And from P3 in the anti-clockwise direction, if I take it, is minus y. So these are the three different angles. Now, the origin or the center of the circle, I'm giving it as O itself. Now, what is this? From this P1, P2, P3, what are the coordinates of P1, P2, P3? And this one 1, 0, I'm writing it as P4. So this is P4. So what is P1? P1 will be, since the angle is x, I can write it as cos x, comma sin x. So since the angle is x, I can write it as cos x, comma sin x. That is P1, coordinates of P1. Now what is coordinates of P2? The coordinates of P2 will be an angle which is a sum of x and y, right? Because it is having an angle x plus y. This complete angle over here is x plus y. So I can write it as cos x plus y, comma sin x plus y. So that will be P2. And P3, when it comes to P3, it is having a negative angle minus y, right? So that I can write it as cos minus y, comma sin minus y. So that will be P3. And P4, because it is on the x-axis and it is on the edge of the circle with the x-axis, I can write it as 1, 0 because it's having a unit radius. So it is 1, 0. I have P1, P2, P3 and P4. Now let's just connect this P1 and P3. So I'm just connecting P1 and P3 over here. So I got P1, P3 connected over here. And also I'm connecting P2 and P4. So P2 and P4 also connected. Now what is the length of P1, P3 and P2, P4? So that's what I'm going to find out here. So next thing, what is P1, P3 the whole square? I'm using the whole square because I don't want to play with roots, square root. So I'm just putting the whole square. So P1, P3 the whole square. What is P1, P3 the whole square? P1 is cos x sin x and P3 is cos minus y, comma sin minus y. So what will be the distance formula according to that? Can I write it as cos minus y minus cos x the whole square plus sin minus y minus sin x the whole square, which is nothing but what is cos minus y? Cos y. So what will be the square of that? It will be cos square y plus cos square x minus 2 cos x cos y plus sin minus y. What is sin minus y? Minus sin. What is the square of minus sin y? It will be sin square y. So sin square y. Then minus sin x whole square is plus sin square x. Then you have sin minus y is minus sin y. then minus sin y minus sin x into 2. So that will be plus 2 sin x sin y. And when you simplify it further, cos square y plus sin square is 1, cos square x plus sin square is 1. So it's 2. So 2 minus, you have 2 common here, and when you take that minus 2 common out, so you can write it as cos x cos y minus sin x sin y. So this is what we get for P1 P3 the whole square, just P1 P3 the whole square, right? Now what about P2 P4? P2 P4 the whole square. P2 is nothing but cos x plus y and sin x plus y, and P4 is 1 0. So when I take the distance formula there, I will be getting it as 1 minus cos x plus y the whole square plus 0 minus sin x plus y the whole square, that is minus sin x plus y the whole square. And when I take the square, I will be getting it as 1 plus cos square x plus y minus 2 cos x plus y, which is equal plus minus sin x plus y the whole square is sin square x plus y. You know that sin square x plus y plus cos square x plus y will be equal to 1. So 1 plus 1, there is a 1 over here, so 2. So 2 minus 2 cos x plus y. So this is what we get as P2 P4 the whole square. So I got P1 P3 the whole square. Now I have P2 P4 the whole square. What should I do with these two? You know that since this is a circle, all the radii will be equal. That is OP1 will be equal to OP2, will be equal to OP3, will be equal to OP4. And also the angles which are covered in the circle inside the triangle. If I say the triangle P1O P3, I'm just not going to prove congruency and all over here. I'm just saying, look at the triangle P1O P3 and P2O P4. P2O P4. These two triangles will be congruent to each other because their radius are equal and the central angles are also the same. So since these two are following the condition, you can say they are congruent. And since they are congruent, can you say P1 P3 will be equal to P2 P4? Or their squares also will be equal? Yes. So their squares will be definitely equal. Now we have the squares, right? We have one square over here, that is 2 minus 2 into cos x cos y minus sin x sin y. And here P2 P4 the whole square, I got it as 2 minus 2 cos x plus y. So these two should be definitely equal. So now I can write it as 2 minus 2 cos x plus y is equal to 2 minus 2 cos x cos y minus sin x sin y. Now this 2 gets cancelled, minus 2 also gets cancelled because this is common, and I can finally write it as cos x plus y is equal to cos x cos y minus sin x sin y. So this is one important formula that we get in terms of the sum of angles when it is cosine. That is cosine of x plus y is nothing but cos x cos y minus sin x sin y. And similarly, you can find out the other sums also. That is, if I'm asked what is sin x plus y. So sin x plus y is nothing but sin x cos y plus cos x sin y. So not in the same form, I'm going to find out the entire proof for this particular identity. So sin x plus y, you have to learn it as sin x cos y plus cos x sin y. Simple. That is sin x plus y. And then you have difference. So when I'm asked the difference, that is sin x minus y. So when I'm asked the difference, in place of y, that is in place of this plus y, what? Put minus y. So try putting minus y. So you have sin x cos minus y plus cos x sin minus y. And when you put that, you will be getting it as, what is cos minus y? Cos y itself. So you have sin x cos y plus cos x sin minus y is what? Minus sin y. So this plus becomes minus. So you have minus cos x sin y. And now you get the formula for sin x minus y also. So what is the formula for sin x minus y? It is sin x cos y minus cos x sin y. Clear? And now when we talk about the last one, that is cos x minus y. What is cos x minus y? It will be cos x cos y plus sin x sin y. So this will be the formula for cos x plus y also. So that is how you find out cos x minus y, cos x plus y, sin x plus y, and sin x minus y. So these are the different formulas for sum of cosine, difference of cosine, sum of sine, and difference of sine also. Now there are two more, not two more, we have for tan as well as cot. Now what is for tan? if I have tan x plus y, what is tan x plus y? You know that tan x plus y is nothing but sin x plus y by cos x plus y, right? Now we know that what is sin x plus y. What is sin x plus y? Sin x cos y plus cos x sin y divided by what is cos x plus y? It is cos x cos y minus sin x sin y. Now to get the final answer for what is tan x plus y, divide the numerator and denominator by cos x cos y. So divide it by what? Cos x cos y. So when you divide it like that, you will be getting it as sin x cos y divided by cos x cos y is tan x plus cos x sin y divided by cos x cos y is tan y divided by this one is 1 because cos x cos y divided by cos x cos y is 1 minus sin x sin y divided by cos x sin y is tan x tan y. So this gives us the formula for tan x plus y. So this is how you get the formula for tan x plus y. In the same way, what is tan x minus y? Put in terms of y as minus y and you will be getting directly, you can write directly as tan x minus tan y by 1 plus tan x tan y. So this is the formula for tan x minus y also. Now, if I am asked what is cot x plus y, what is cot x plus y? Cot x plus y, you can write it as cot x cot y minus 1 by cot y plus cot x. This is a formula for cot x plus y. And what is cot x minus y? The same way, cot x cot y, instead of minus 1, put a plus 1 divided by cot y plus cot x. You have to write it as cot y minus cot x. So this is the answer for cot x minus y, cot x plus y, tan x plus y, and tan x minus y. So we have studied for sum and difference of cosine, sine, tan as well as cot. Now let's just do the first question that we discussed, that is what is the sine 75 degree? What is sine 75 degree? I can write sine 75 as what? Sine 30 plus 45. So now it is of the form sine x plus y. So what is sine x plus y? We know that sine x plus y is nothing but sine x cos y plus cos x sin y. Yes. And when you write it like this, you can also write it as sine 30 cos 45 plus cos 30 sine 45. 1 by 2 into 1 by root 2 plus root 3 by 2 into 1 by root 2, which is nothing but 1 by 2 root 2 plus root 3 by 2 root 2, or it is root 3 plus 1 by 2 root 2, which gives us the final answer for sine 75 degree. In the same way, if I am asked what is tan 105 degree, what is this tan 105 degree? So tan 105 can be written as tan 45 plus 60, right? Yes. And what is tan A plus B? Tan A plus tan B by 1 minus tan A tan B. So using that, you will be getting it as tan 45 plus tan 60 divided by 1 minus tan 45 tan 60. Put all the values. Tan 45 is 1 plus tan 60 is root 3. So 1 plus root 3 by 1 minus 1 into root 3, that is again root 3. You can multiply with the conjugate 1 plus root 3 in the numerator. So you will be getting it as 1 plus 3 plus 2 root 3 by 1 minus 3. That is 4 plus 2 root 3 by minus 2. That is nothing but minus 2 minus root 3. So this is the value for tan 105 degrees. So we have used the formula for sum and difference, and also we have found out how can we find the answers for questions which are of this form. The questions may not seem directly of that form, but you can use that and find out the answers for these kinds of questions, that is 105 degree as well as 75 degree. So these two examples were there for sum of the angles. You can use the same for what? Difference also. So this is all about trigonometric functions of sum and difference of angles. More about trigonometric functions you will be learning in the upcoming sessions. And now, for the time being, let's have a quick recap of this session.
Manorama Horizon. Learning made simple.